Uh, yeah, hello friends. If anyone joined, please ping in the group or in the live chat. We'll start in 2 to 3 minutes. Okay, perfect. I think a few of them joined. So let's wait for 1 to 2 minutes, then we will start the class. Okay, I think let's start the class. So today we will cover the OOPS concept. So the Python OOPS concept, and we will also do a little project on this. So I will first tell you what is OOPS and what are its use cases, and then we will see the basic concepts of different OOPS and a little project. Okay, let's start then. So in OOPS, basically there will be a class concept. So what is class? Class is basically a blueprint, okay, based on which we can create a real-time object. For example, let's say a blueprint of a house, right? So we can't live in a blueprint of a house, but from the blueprint we can create different house and there we can live. That is known as object. So let me give you an example, the example which I give to everyone. So let's say we have one object named human. Okay, so let's say God wanted to create a human. So God first will decide, before creating human, what will be the attributes or properties that will reside in human. Okay, so let's say it will have these attributes. There will be name, age, height, weight, like this. Okay, and there will be certain tasks that will be performed. Okay, so a human can perform certain tasks. Let's say those things will be eat, talk, okay, walk, like this. So before creating human, God have decided that the human will have some name and age, and it will have some, it can do some, perform some task like eat and talk. Okay, but this is a blueprint. Okay, this is a blueprint. After that, from the blueprint, let's say God have created two gender, right? We have two gender, one is male and female, or boy or girl. So let's say God has created two gender. One is a boy and another one is girl. Now these are the real world object. Okay, so human is a blueprint, but in the world God has created boy and girl. Okay, these are the real time object, or which we can touch, we can see, right? Boy and girl. So since boy and girl are created from the blueprint of a human, that means the same thing, right? Boy and girl will have the same properties and attributes. That means it will have this name and age, let's say it will have this name and age. And it will perform some task, that is eat and talk. So now this is the real world view, but in the term of OOPs, what we can say is this human is nothing but a class. So from the class, whatever we have created, that is boy and girl, these are objects. And whatever this name, age, eat, talk, these are basically this name and age, these are known as attributes or properties. Attributes or properties. And eat and talk, these are methods. Okay, so to perform some task, these are methods. So this is the whole structure of the object-oriented programming. So any issue, friend, in this, please let me know. Now what we will do, so let's do a simple program of this class. So FastAPI day 2, let's create a folder. Oops, and let's do the coding here. Okay, let me zoom it a little bit. So here the first one is the class.py. Okay, so how to create a class in Python? So to create a class, like the same thing that we have done for this human, what we will do, we will write class human. Okay, then colon. Then since it's a blueprint, we need to give the attributes, right, or the properties of a human. That means here the attributes of the properties are name and age. So we can define name as one attribute and age as one attribute. So now these are the attributes or properties. Now it will also have some methods. Okay, so methods are nothing, the function itself are known as methods. Okay, but whenever a function we use in a class, that time we call that function a method. Then how to write a method? Then def the method name. So what is the method name? Let's say eat and talk. Let's say we will implement this talk method. Then talk. So the first parameter in a method will be always self. So this you need to give mandatorily, self. So self is nothing, it will store the memory reference of an object. We will see this in a later moment. So here let's say I want print I am talking. So I have created a class blueprint. Okay, but now this is a blueprint only. There is no real world object. So to create a real world object, we need to create an object. So what is the syntax for object creating? Let's say we have a person 1, then we will write human bracket. So now we have created one object, person 1. So this is nothing but an object. So this is an object or an instance. Now from this instance we can access name, age or the method from there. Like say if I write print person1 dot name, it will print the name. Let's say if I write python class dot py. Okay, so currently there is a blank string, so it's not printing anything. So to set the name, we need to set it via this object itself. So the object name, that is the person1 dot name, then let's say I have set it to max. Then person1 dot age equal to 20. Now if I write the code, say it's printing the name max. So any issue friends till now, please let me know in the comments. Okay, now what is this self? So first we need to know how this object is being created. Okay, so whenever we have written this thing, class human, this line, so whenever we have written class human this thing, so what's happening inside? So internally it's creating a memory space, okay, in our RAM. So what is the class name we have given? Human. So a memory space is allocated for this human. Then we have some attributes in this class, right? That is name and age, and we can have some method. So let's say in the heap memory we'll have something. So one section, it will have all the attributes. So name and age, these are the attributes. So name, age, and in one section it will have the methods. So currently we have only one method, that is talk, like this. Now what we are doing here, we are creating an object, person1 equal to human. So what is this happening? Whenever we are creating an object, so a separate memory location has been created for that. So that is the object person1, and it's allocated into some memory location, let's say 2002. Since this person1 is the object of human, so this is an object from human, it will have all the properties and method of a human, right? Because we have created this person from the blueprint of a human. So this person will have this same name and age, and also it will have this talk method. Suppose if you create another object, let's say person2 equal to human, so what it will happen? So it will create another memory space with person2, and it will assign a new memory location for that, let's say 3003, and same it will have all the properties of name, age, talk. It will have the name, age, talk, the same attributes. But every time we are creating a new object, it's allocated into a new memory location. Okay, so what is this self? So self is nothing. Self will denote the memory location itself. So self, what it will do? It will denote this memory location itself, this 2002. Okay, or wherever the object is created. For example, if I call this method person1.talk, or this person1, let's say I am calling person. Before that, let me print the person1. What will happen if I print the person1? See, it's printing the main, which class object is this, that is human class object, and the memory location. in which memory location this object is created. Okay, now let's do one thing. Let's print this self itself. Here I am printing self value is self, and below this I am calling this method talk, person1 dot talk. If I run this, so see, self value is nothing, it has the same value of that object. Okay, so what is happening, this self is pointing to the same memory location from which the method has been called, from the object. Okay, if I write person2 dot talk, for example, here if I write here person2 dot talk, then what will happen, this self will point to 3003. If I write person2 dot talk, then what will happen, then it will refer to this 3003. So self is nothing, self will point to the memory location of the object itself. So any question, friend, here? If any question or any doubt, you can ping in the chat. Okay, and another thing, let me tell you. So this self is nothing. In many programming languages, this is known as this. Okay, in JavaScript, in Java or C#, this is known as this. Okay, whatever the this in other programming language, that is self in Python. But one thing you need to see, you need to define self as the first parameter of a class, okay, of a method. Because by default Python will send this object memory location in the self. If you don't give self here, so see, it will give error. Okay, because could not bind talk because it is missing a self. Okay, so self is mandatory. Now you will see the next concept, that different types of methods. So there are three different types of method. One is instance method, second one is class method, and third one is static method. So these are the three different types of method available. So anyone here know what are these instance method, class method or static method? Okay, let me tell you. So instance method is nothing, the method that can be called via object itself. For example, this one, person1 dot talk. Okay, since this method we are calling via this object, this is known as instance method. Now what is class method? So class method is basically a method that is available at the class level. Okay, that means it will be available throughout every object. So I will give you an example. Let's say we have one class, let's say car factory. Okay, now in car factory, suppose there will be some method, okay, that will be related to object only. For example, what will be the design of a car, like this. Okay, so this will be object specific, but there will be some methods that will be class specific only. For example, let's say, or let me give you another example. Let me give you an example of an employee. Let's say class employee. So in class employee, what is the, we can define some method that will be shared by all the object. Okay, that will be common for all the object. For example, let's say a company name. Let's say ABC Corp. Okay, and let's say total employee. Let's say company name. So if the company name is changed, so it will be applicable for all the employees that is working in that company, right? For that employee. So that means if I create a method, let's say def change company name. So that means this company name change will be affected to all the employees, right, of that company. That then we can give this, let's say here I will give some print company name change. So since this will be applicable to all the object of this employee, okay, then we can give this as a class method. So this will be a class method. Okay. Okay, so here I need to give a CLS for the class method. So this is whenever we are mentioning some class method, then we need to mention CLS. Okay, this is a mandatory. For instance method, we need to give self, and for class method, we need to give CLS. So CLS is pointing to this class itself. So we don't use this class method so oftenly. So if you want, I can give you a detailed explanation of this class method in a separate video. Just let me know, or what are the use case, but we don't use this class method so often, but you can have an idea of this. Okay, before going to any concept or any question, friend, you want? Okay, now the static method. So static method is nothing. So whenever we want the method to calculate or to do some task without knowing what are the different changes in the class variable. Okay, so it doesn't depend on any of the other variables. It will perform their own task and give us some response. Okay, for example, let's say we have some class calculator. Okay, and here we have given def add, and let's say it's having two variables, a and b. Return a plus b. So see, friend, here let's say here we have some other variables. Okay, let's say we have some variable of, let's say, test. So this function add, is it dependent on anything of this class or object? No, right? Because the function will only, or this method will only take two arguments. It will do some mathematical task and will return the response. So it is not dependent on any other functionality. So for this type of method, where it will only do some calculation task or any other type of performance, we can mark this as static method. Here we can do static method. So in static method, friend, we don't need to specify self for CLS as the first parameter. Okay, so it will act like its own. So it's not nothing. So it's like we are defining just a normal class. Let's say def add a comma b, return a plus b, like this. So this is also like a static method, but since we are using this in a class, we are telling this as a static method. Okay, so this is not dependent on class, but we are adding this in the class so that in a class we can have all the related functionalities together. So how to call this static method? So for static method, we don't need to create any object. We can directly call a static method from the class itself. Okay. So if you see result equal to class name dot the static method, that is the add. You can pass two numbers there and it will give us the response. See, it's giving us 30. So this is the static method. So here we complete the three types of method. Next in OOPs, we have constructor. Okay. So constructor basically is the term used in other programming languages. Here we don't call it as a constructor in Python. Okay, we call this as a magic methods or init method. But the concept is same. Whenever we wanted to assign some value during the creation of an object, that is known as constructor. Okay. So how to define a constructor in Python? So let's say class. Let me remove the other class. This class EMP. Okay. So in the EMP class, how to define a constructor? We can write def underscore underscore init underscore underscore. So and then we can write self. Okay. And then if any other parameter, but let me just type print employee created. So what is this underscore underscore friend? This is known as underscore underscore any method name. In Python is known as magic method or dunder method. So why magic method? Because this method will be called automatically by Python. We don't call this method explicitly. Like these methods, if I say talk, we are calling this method explicitly, right? We are calling this here. Then only this method will be invoked. But for this init method, Python will call this method and it will be invoked automatically. We don't need to call this via externally. So in front end, this is also equivalent to front end lifecycle loop, right? In React or Angular, we have lifecycle loop, which is automatically called by Angular or React. So the same thing here, this init. So there are many magic methods. We will see one or two here, but there are many magic methods available. Now, when this method will be or this init constructor will be called, whenever we create any object, at that time this will be called. Let's say I am creating one object e1 equal to emp. Okay, I am not printing anything. Let me clear the screen. See, this employee created has been called. We are doing nothing. We are just creating an object. At that time only, this init method get called, okay, by Python itself. That's why this is known as magic method. And how to write magic method? We have to give 2 underscore, then the method name, and then after that 2 underscore. This is the way we write a magic method. So what is the use case of this? So let's say we have some employee name, right? And salary. Now suppose I wanted to assign some value to this name and salary whenever we are creating this object. That time we can pass here name and salary. Let's say I give it a short form N and S. N for name, S for salary. Then here we can write self dot name, which is referring to this, equal to N, and self dot salary equal to S. And here we can pass the name and salary. Let's say name is Sam and salary is 20,000 or 2,000. Now if you try to print the name, see the Sam is printed now. So by this you can set the value at the creation of the object itself. Okay. And another thing, let me tell you. So when you are defining like this, self.name equal to n, self.salary equal to s, you don't need to define this name and salary in the class level. Okay. This is optional because Python internally will define this variable name and salary. See, if I run this program now, still it will work. Okay. So you don't need to tell this explicitly. Python will automatically create this name and salary portion. How would you design a service layer using constructor-based dependency injection FastAPI while maintaining loose coupling and testable? Okay, so here Rehan has asked the question: how would you design a service layer using constructor-based dependency injection FastAPI while maintaining loose coupling? Okay, so in FastAPI basically we will have the concept of this dependency injection. So dependency injection, which we will see a later section. So there we will use some solid principle. So in the solid principle we have a list scope principle that we can, first of all, we can create a separate segregation and interface layer for that, or else what you can do, let me, since it's a core Python, dependency injection will not work like that. But what you can do here, let's say if you are doing class EMP and if you are doing this. So another thing, let me tell you, Rian. So dependency injection mostly we will use. So which one you were telling? If you can specify the question again. Okay, in the meantime, let me that thing. Okay, now we are going for that. Let's say. So as per that, Rian, whatever I asked for the dependency injection, that is how to create a dependency injection on the constructor level. So there basically in FastAPI, we use one dependency injection in the router level. Okay, and another thing we can use is that we can create a data access abstraction layer. So using the interface repository or the abstract method, so using that you can create that. So but in the constructor basically we don't create like that as a dependency. So basically we can create some factory function. Let's say def, you can create get user data like this, and then here in the session you can create dependency like this, which will be a depends keyword with the function name, the function whichever you wanted to run. Okay, without creating the instance for that. Okay. Now the next concept that we are going for that is that we have created this one, and let's say now we'll go for the encapsulation. So encapsulation is nothing. Suppose you can imagine a TV remote control. Okay, so or a capsule of a medicine. So the capsule is basically the outer layer. Inside that you can have multiple properties, right, or multiple herbal concept. So let's say it consists of 2 or 3 herbal that will help to cure your sickness. Now this capsule is made of that, but you don't know what is inside the capsule. You just eat that capsule so to cure your fever or any of your illness. Okay, that is known as encapsulation. Means encapsulation is hiding the internal data and restricting direct access of the inner working of an object. Okay, For example, the ATM machine. In ATM machine, basically we just use the interface, right? We don't know how an ATM machine works. Now, let's say if we for the encapsulation, how to write a code for encapsulation. So basically, let's say class. Let's say if we create a secure wallet. Okay. So let's create a constructor. Self, and then let's say initial balance. So we can also assign the typing here. So let's say this is float. And let's say here we will add that balance. Let's say self underscore balance equal to initial balance. Okay, so suppose this is a secure wallet where in the constructor we are taking our balance, initial balance, and we are setting that in our balance. Okay, so in Python this underscore is known as private variable. Okay, so there will be two underscore that is private, but the best way to use that is a one underscore to tell that this is a private or a protected variable. Now how to, since this is a private or protected variable, we can't access this via an object. Okay, so how we can access this? So for that we can use getter and setter. In Python basically we don't have this getter and setter explicitly. For that we use a decorator property. Okay, so for getter what you can do, you can write def balance and then self. So it will return. You can use this for returning. Okay, what is the type you wanted to return? Suppose I wanted to return the type float. So here you can write return self dot balance. Okay, so this is a getter, but how will you make this as a getter? For that there is a decorator known as property. So this property keyword will make this balance, this function as a getter function. Okay, so now we can use this as a variable. We will see this and how to use setter in Python. So for that we need to give whatever the function, whatever the getter we have created. So this is a getter, so we need to write that. Then dot we have to write setter. So now this will act as a setter, the below function. Def balance self and then the amount. Float. So here we can give if amount is less than 0, then you can give some, you can raise some exception. Okay, so how to raise exception in Python? You can add raise, then the value error or any error, and then you can give balance cannot be negative. If amount is greater than 0 or greater than 0, then you can set the balance to amount. So now you have created a getter and setter, and this is an encapsulation. See here, this balance is a private variable. We are not changing this private variable using directly. We will use a property that is getter and setter to change and get the value. So how to set a value in setter? So we will use like this. First we will create an object. Let's say obj equal to secure wallet. Let's say the initial balance I give it 100. Let's say 0.0. Now I wanted to update the balance. Okay, so what we can do? We can write obj dot. So since balance is, this is the setter method. So we'll use this method name directly as a property. That balance equal to, let's say I give 150.0. Now if you write print obj.balance and run this, see it has set to 150. Okay, but if you try to give some negative value, let's say -20, right? See, it's giving a value error. Balance cannot be negative. Okay, so using this is an encapsulation. So there will be some private property. So to change that private property, we use getter and setter here. So any problem here in this code, please let me know. Okay. So now we are going for the next concept, that is the inheritance. So inheritance is basically whatever the trait or whatever the function or the attributes you inherit from your parent. Okay, suppose many say, right, the boy looks like his mother or father. That means the trait or the properties that the children has inherited from their parents, that is known as inheritance. In programming also we have this inheritance concept. So the simple one is like this. Let's say class animal. Okay, let's say in this animal we have a property called name equal to animal, and let's create a function def test, let's say, using self print animal class. Now we'll have another class, that is, let's say, dog. Okay, now dog will inherit this animal. How? So the inheritance concept here is we will give a bracket and then write the class name. Okay, so that means dog is now inheriting from the animal. So if I say pass, what this means, that all the code, all the animal code will be available here like this. That means it's inheriting all the code, properties and method in the dog. How we can do, check this? If I see here, let's say d equal to dog. Okay, and if I try to print d dot name, then okay, sorry, so here I have added a minus value, that's why. See, the name is animal itself, so it's inheriting from the parent, this name property. So this is known as inheritance. So getting the properties and the methods from the parent one is known as inheritance. So another thing, let me tell you. So suppose in parent we have some constructor. Okay, here self, and let's say it's getting some data. Okay, and here we are printing the data. So here also we can create a constructor. See, and how to call the parent class constructor, this init, using a super keyword. So this super keyword will help us to call this parent class constructor from the child class. So what is the syntax? we'll use super. That means the parent class. Super will refer to the parent class, that is animal. Then the constructor method, that is the init method I am calling, and I am passing the data. So from here we can pass the data. Let's say test data, and if I run, see this test data, that means here itself it's printing. So we are passing this data from this child class to the parent class. So whenever you wanted to call any method from a child class to parent class, we use this super keyword. So using the super keyword, we call that. Okay. So this is the concept of inheritance. Okay. Now, after inheritance, there is a concept of is a relationship and has a relationship. This is very important. Is a relationship and has a relationship. So anyone know about this is a relationship and has a relationship? Okay, so sorry, let's say what is happening for the inheritance. So this is an animal, right? And this is an example of an let's say the dog. So what we are doing, the dog is inheriting from this, let's say this dog is inheriting from this animal, right? Now, since the dog is inheriting from this animal, then what is this? We can say dog is an animal, right? Dog is a animal. Okay. Now, this is a very tight coupling. So why this is tight coupling? Let's say if somehow all the animals get destroyed, okay. If all the animals get destroyed, that means the dog will also be destroyed, right? So that means dog is totally dependent on animal. If somehow, if parent class get destroyed or hampered, the child class will also get affected for that. So that's why easy relationship is a tight coupling relationship, and it will be very difficult to maintain it in the near future project. So for that we try to avoid this easy relationship, that is inheritance, go for has a relationship. Okay. So what is this has a relationship? Now say I will okay, I think Rehan has some question. When designing a large FastAPI application, what responsibility should belong to the route layer, service layer, repository layer, domain layer? Why? Okay, Rehan, after this I'll just tell you what, but it's a good question. I'll just tell you. Now this has a relationship. Before this has a relationship, let me tell you, Rehan. After that I'll just tell your answer. So has a relationship, how has a relationship? That's a computer, okay. Let's say I have a computer. So we can assemble one computer, right? So for assembling one computer, what do we need? We need one RAM, let's say, hard disk, or let's say CPU also we need, right? A processor or CPU. So using this, we can build a computer. Now, Suppose if the RAM get destroyed or the RAM is not working, so what you will do, you will replace the RAM with some new RAM, right? That means the computer is not affected. So computer is totally not affected by RAM. Suppose if CPU get hampered, you will just change the CPU, right? So it's not totally tightly coupled with CPU, that if CPU get destroyed, the computer will also get destroyed. Okay, so this is known as has relationship. That means we can tell computer has a RAM, computer has a CPU, like this. Okay, before this, let me answer Rehan's question. When designing a large FastAPI application, what responsibility should be to the route layer, service layer, repository layer, and domain layer? Okay, let me tell you. So let's say, suppose Rehan, this is your FastAPI application. Okay, how the things happens? Whenever a request is coming from, so let's say the request is coming from the front end. Okay, let's say the request is coming from the client side. So the first time it will come to the main.py or the root, the bootstrap. So from where the FastAPI is working, okay, main.py. Then we have different service file. Okay, so what is service file basically? In service file, we basically write all the business logic. Okay, let's say we have business logic regarding order. How many orders are placed, the order needs to be dispatched when, all this logic will be under order. Then we'll have some service for authentication, right? For the login, register, then forgot password, everything. For authenticating a user, we need an auth service. Let's say there will be some product service, right? How many products are there? If you wanted to add new product, these things. So in service layer, basically, we write all the business logic. Okay, if we wanted to add new product, we wanted to delete product. So you can say all the CRUD application, create, read, delete, and update. All these things will be under this service layer. Let's say this is service layer. Now this main.py will have multiple route file. Okay, so let's say we have this route file. So this route file will redirect the request to the responsible service layer. Suppose if anyone have hit and leak like this API, suppose they wanted to add product, so it will go here, the route will check, okay, this is add product, that means I need to navigate this to this product service. Okay, here all the logic for this add product is written in this product service. Now coming to this repository layer. So repository layer is nothing. This will, let's say, is an order repository. Let's say this is product repository. So repository layer, in repository layer we write all the database related activity. Okay, suppose from the repository layer everything is connected to this database. Let's say there is a DB, all the code like insert some data into the DB, delete some data into the DB, everything will be written under this repository layer. Okay, so this is the task of a repository layer. And route layer, it will just redirect in which service the functionality should go. Is this clear here? Any question regarding this? Okay, if any question, let me know in the chat for this. Okay, now since we have seen this has a relationship, let's take an example how this has a relationship work in the coding structure. So first we will create the separate component. Let's say class CPU. Okay, let's say we have this process which is self. let's say print processing started. Then we have class RAM, let's say. There, let's say load. Let's say it is load, and let's say print loading data. So these are the separate component. Now we are creating a computer class, right? Class computer. Here we are writing. So first we will create a constructor. Okay, here we are, let's say we are assembling the computer. Okay, we are assembling this computer. So for assembling this computer, what we need? We need a CPU, right? Then we can write self dot CPU equal to, we will create a CPU instance method there. Now we write self dot RAM equal to, let's say this RAM. We'll create a, so here we are adding, okay, we are creating this computer, okay, we are assembling the computer. So here the assembly is done. Now we'll start the computer. Okay, let's say dev start. So first what we will do, the RAM will start, right? Let's say self dot RAM dot load. Then we'll start the CPU, right? Self dot CPU dot process, and then the computer will be started. Now we can create the computer object. And then we can create the start. Now if I write, see what is happening. First it's doing, sorry. See, first we have created the CPU, that means the processing started, and then what is happening? The RAM, it's loading, this loading data is happening, yeah, loading data, and then the computer started. Okay, so this is a hazard relationship. In hazard relationship, we avoid the inheritance concept, because in inheritance this is a tight coupling. If the parent class get hampered, this child class will also get hampered. But here, see, the class, this is our main class, this is not inheriting from this. Okay, we are just assembling here. So this is a hazard relationship. If any of these get hampered, we just need to change this. It will not affect our main class. So this is the hazard relationship, and in programming language this is known as composition. This is known as composition. So these two are very important concepts, easy relationship and hazard relationship. So any question regarding this? Between this easy relationship and hazard relationship? Let me know, friend. So this is the different concepts that we need, and we need to know this easy relationship, hazard relationship. Using this in the FastAPI, we will create many different endpoints. So any question, query, let me know, friend. Okay. Now let's go to the next concept, that is the polymorphism. Okay, so polymorphism, everyone know that it is like a same thing will have a different form. Okay, let's say for example a power button in laptop or a power button in car, it may look same but the functionality is different, right? If you power on for a laptop, it will boot the operating system, but if you do it for a car, it will start the engine. Okay, so that means the same type of thing, looking thing, but doing different action. So that is basically polymorphism. So in practical code example, I will show you how polymorphism we write code. So let's say we have two types of notifier. Okay, let's say email notifier and SMS notifier. Let's say class notifier, let's say def send, it is self, and message which is of type string. Let's say print email is message. And let's say we have a same type of notifier, that is class, let's say SMS notifier. Here also def send. Okay, here also message str, let's say print SMS is message. Okay, now see, there is two email notifier. Okay, in our FastAPI application, let's say we have two notifier, SMS notifier and email notifier, but both have same function, right? Both will do same, but they will send in some different channel. This email notifier will send in email, and this SMS notifier will send the message in our SMS mobile phone. So the task is same, but the channel is different. So it's an example of polymorphism. But how to write this code in a FastAPI application? We need to create one method, let's say notifier. Okay, then first will be a notifier object. Okay, and then let's say the message. So this notifier object will only take those type of object. This notifier object will only take those objects in which the class has the send method. Okay, if we pass any other object apart from the send method, this will give us error. So we can say notifier object dot send and the message itself. So how you can test this? Let's say I created one email notifier. Okay, now I am calling this method notifier, and I am passing this email notifier and message. Test email. Okay. Now if I run this, see, email is test email. It's calling this email notifier. Now if I, for the SMS notifier, I will create an SMS, then I will create SMS notifier, then again I will call this notifier, but with this SMS. See, now this SMS is test email, so it's coming that same thing, but it's calling this SMS, this one. The message is same, test email, that's why. But see, this notifier of the function, it's taking an object of those class which have the send method. Suppose if you pass any other object of class that don't have any send method, here it will give an error. It will raise an exception. Okay. So this is how we create a polymorphism code. But in project, let's say if we are going for design pattern, how to design this then? So this is not a suitable solution. In production, how to write this code? Let me tell you. So for every notifier, this send method is mandatory, right? Let's say suppose in near future, I create another function, class. Let's say class AWS notifier, let's say. Okay, and by default I forgot this send method. I created this method, def sending self. Here let me take AWS. Okay, self and message, let's say this one. Now this will give me error, right? Like suppose if I create this AWS object and AWS notifier and pass this AWS notifier, this will give me error, right? Because this AWS object, this class, don't have the send method. It has the sending method. So if I print this, so it give me error. See, attribute error, AWS notifier object has no attribute send. Okay, so it's giving me error. So what is the best way to tackle this scenario? So for this, as a senior developer or as an industry standard, what you need to do, you need to import abstract base class. So basically from ABC, import ABC and abstract method. So what is this abstract method? So abstract method or an abstract class are those class in which the method will not have any body, will not have any implementation. Okay, how we can write this? I will show you. Let's say class, let's say notification service. So it will extend from this ABC, abstract base class. Now we can create a method, let's say def send, which will be of self, and it will take a message of string. But it will not have any body. Okay, so there will be no body. So here I will just mark this as abstract method. What does this mean? This method will not have any body. Whatever the child class will inherit from this notification service, it's their duty to implement this method. It's not the parent duty. Okay, so that means email notifier, I will just inherit from this notification service. Now this email notifier will inherit from this notification service. Now it's duty to implement this send method. Same from this SMS notifier will implement from this notification service, and this AWS notifier same for this notification service. Now if you run this, see it giving me error AWS notifier because it doesn't have send. Okay, so here you will have to send, since I don't have Pylance installed, otherwise it will give me error here. Okay, so we need to implement this send method. Since this notification service have this send method, and I need to implement this method. So now if you write this, see now AWS is working. So this is the way you write a abstract base class, okay, or a polymorphism code. So any issue, friend, here, just let me know if any concept or any. Okay, now the last concept I will define is a data class. Okay, let me remove comment everything. So let's say I have a class user. Okay, and I have this def init method. Let's say here I am assigning some value, self.name. So it let me take name and age as a property. Here assigning the name, self.age equal to age. Okay, now how to initialize this? We have also in user, and then we can pass Sam and 20. Now if you print this u.name, So it's giving me Sam, right? But if I wanted to print the whole object, how it will show? See, if we wanted to print the object, it will print the memory location only. But if I wanted to show this message to any user, so user will not understand, right? Or even we also can't able to debug what are the value we have assigned to this name and age property. Then how to change this message? So for that, Python give us another magic method, that is representation, that is REPR. So REPR is nothing, it will represent the object output structure. Okay, how the output will look like. So here let me give this structure like this: return, this is the user class, basically user, and then the properties. Let's say name is equal to name, sorry, self.name, and age is equal to self.age. Okay, now if I print this, see, now the object is not giving the memory location, it's giving in a user readable format, right? User name is Sam, age is 20, correct? But for this thing we have to write so much of code, right? I have to initialize the value using the constructor, then I have to create another magic method. Here I need to define how the output would look like. But we can do all this thing in a single line of code, like we don't need to write everything. So for that we use data class. From data classes, import data class. So how we can write the same thing? Then we will write @data class, then we will write class user, just we will give name and the type. So name will be string type, age will be int type. That's it. We don't need to write anything else. This whole code is representing the above code. Python internally will convert this code into this above code. So if you run this code again, see, I'm getting the same thing. So it's giving me the same output like this, right? User, the name is Sam and age is 20. It's setting everything. So data class is nothing. If you use data class, internally data class will auto generate this method. One is this magic method will be auto generated. Init, second one is representation, and third, another magic method it will also auto generate, that is equal. So that is not so much of use. So this magic method will be automatically created using the data class. Okay, so we use this data class only for the models. Okay, we generally don't write heavy business logic under this data class. So another thing, let me tell you. So in data class, we can also make it as frozen. Okay, so what does this means? In the data class, there are many options available, right? So there is option called frozen, true. So what it will happen? Suppose later on, if you wanted to change any value, see, it will give error. That means once it's frozen, you cannot change this attribute value later on. Okay, so this is the use of this data class. So we use this data class for the configuration object. Okay, like later on in the FastAPI, whenever we will create models, we can use this data class frozen true. That means it will be frozen and it will not be, we can not modify the properties later on. Okay, so that's it, friends. So these are the OOPs concept basically we need for the FastAPI. In next session, we will do one practical project of all the OOPS concept, and there you will understand more of this. So we will try to do 2 practical projects. If any question, let me know in the chat. Then I am now open for the Q&A. Okay, I think there is no doubt. So let's close this session today. So next session we'll do a project, practical project for this. Okay, thank you friends. Yeah, if any question, you can use the Discord group. There I will try to answer every question.